Is it visible to everyone? Is it visible to everyone?
Yes, sir.
Hello.
Yes, sir, it is visible.
Okay, fine. Okay. Now, earlier lecture, we have discussed about the compressor, heat exchanger, and equipment layout. So, in heat exchanger, we have discussed about the heat exchanger and respective their layout. Now, we will discuss the the next arrangement in heat exchanger. We have discussed the different kind of heat exchangers. So we have seen basic types used in chemical process industry: fixed tube sheet heat exchangers, U tube heat exchanger, floating heat type heat exchanger, and fourth one is kettle type heat exchangers. And we have discussed the basic principles adopted in the heat exchanger pipings. So these basic principles, the heat exchangers, so the working space should be kept clear of any piping and accessories. And we have to consider their respective arrangements for particular accessories to facilitate channel, cell bore, and tube bundle removal as well as maintenance and cleanings. Now, excessive piping strains on the exchanger nozzle from the actual weight of pipe and fitting from forces of thermal expansion should be avoided. And the piping shall be arranged in a such a way that no temporary support will be required for removing the channel and tube bundles, and provide easily removable spool pieces, flange elbows, brake flanges, or short pipe runs to provide adequate clearance for the operation of the tube removals. The pipelines with valves and control valve should run along with the access, close to the exchangers. Pipeline connecting the exchanger with adjacent process equipment can run point to point just above required headrooms. Steam lines connecting the header on the rack can be arranged on either side of the exchangers. Wall handle should be made accessible from the ground and from access way. This access way should be used for arranging manifolds, control valves, stations, and instruments. To avoid condensate drainage towards exchanger, the prepared connection for steam lines is to be top of the header. However, there is nothing wrong in having a steam connection from the bottom of the header if it is at the lower points. The standard dimension related to heat exchanger pipes. I will see the standard dimensions pipes. See in piping arrangements. So these are the standard arrangements are given. So based on that, we can consider their respective alteration can be suggested in order to require to optimum piping arrangements. And consent from the process group is required to ensure that these will not affect the thermal design of the heat exchangers. The cost increase in modification can be more than offset by the cost effective pipings. This factor influence the decision on piping routing as well. Elbow nozzle permits lowering of heat exchanger to grade have better accessibility to walls and instruments. For this purpose, we have to consider their respective arrangements, the piping arrangements. So here you can see the exchanger elevation showing the location of pipelines runs in relation to main pipe racks. And this one is that is a nozzle, reduce height, the stack exchanger. So elbow nozzle permits lowering of heat exchanger to grade have better accessibility to walls and instruments. And here angular nozzle can have one or two bends in the pipelines. So we can save the help of angular nozzle can save one or two bends in the pipelines. The maximum angle from the vertical center line can be about 30 degrees. So here you can see through this sketch there is an angular connection for top nozzle and angular connection for bottom nozzles. Concern the horizontal exchanger can be turned vertical for converging a floor space. Vertical exchanger can be changed to horizontal when installation height is restricted. The exchanger saddle can also be located to adjust to a lineup or combined foundation design. the interchange flow media between the tube side and sail sides. This can give the different advantages. We'll see first advantages if hotter liquid is allowed to flow through the tube, this will minimize the heat loss and avoid use of thicker sail insulation. If high pressure fluid flows from the tube side, only tubes, tube sheets, channels, and covers have to be designed for high pressure, and this reduce sail side thickness and the cost. Next advantage, that is corrosive liquid should pass through the tube so that only the tubes and the channels have to be made of corrosion resistant materials. If one medium is dirty and other is clean, passing clean through the sail will result in easier to bundle and removing cleanings, and sail side volume is much more tube side, and hence vaporization or condensation of free flowing fluid is more effective in sail. So the next advantages when the hazardous chemical or water pass through the sail, the leakage will contaminate the cooling tower. Other hand, the can when process material and initially leakage and when process material atmosphere, simplifying the flow path to improve the piping. So that kind of process parameters we can simplify in the different kind of process. So through this sketch, we can see the vent sides. So here we can simplifying the flow path improves piping designs. So first one is the conventional condenser arrangements, and here consider most economical piping provided by rotating channels 180 degree. So here we can improve the flow path in the piping designs. So next path is system has loop and pocket and can improve this with gravity flow suction line obtained by changing direction of flow through exchangers. So with the help of this path, we can improve the piping design. In next path, that is zigzag flow patterns. Now we can set piping and better flow pattern produced by relocating the nozzles. With the help of this path, we can improve the piping design in process industry or chemical industries. Now next parameter is process and storage vessels. The basic set of information required for the equipment and piping arrangement for the process and storage vessel does not differ from those of the other equipments. Design methods and conceptual details are also differ very little. The process vessels can be classified on the basis of function like surge volume to hold liquid for a specific length of time. First classification. And second is a based on liquid vapor separation or immiscible liquids with different specific gravities. This category include reflux drums, surge drums, process liquid collection drums, drums for sieves, steam and condensate drums, clusters and seats for steams. These could be horizontal or verticals. Now, next one is what are the internals? Often agitators for mixing operations can be simple reactors with agitators i.e. or cooling or heating coils or jocket. The material of construction can vary from carbon steel, stainless steel, and glass line. These reactors are normally verticals. These vessels are located in a process flow sequence. The area required around reactor is much more compared to other process vessels. The manual loading of these, if they required also, will be facilitated. Hence, this reactor will be located passing through the operating floors with the manholes located at accessible levels. Space for utility manholes and process inlet manholes, if required, shall be provided for in the layout. Now, next, storage vessels and tank can be classified based on two categories. First one is intermediate storage, generally located adjacent to process unit or buildings. And second, feed chemical or product tanks. Remotely located, the area being identified as tank farm with its diking and acid proofing requirements. These tanks are conical roof atmosphere storage tanks to store bulk chemicals. If the storage demands high pressure, these are designed as horizontal bullets or spears. The relevant statutory requirements govern the layout of these storage tanks, and these specs are already covered in the development of plot plans. Now, next paragraph is piping arrangements. So, here piping associated with these vessels is a simple economic of piping and access to walls and instruments depends on well oriented nozzles. The nozzle and support orientation can be evaluated as shown in this sketch. Now, first component is inlet or outlet nozzles. Vapor or liquid inlet is a place on top at one end. See, here you can see the inlet or outlets is a place on top at one end. Bottom inlet is also possible and can be located at the bottom of the tank or at the bottom of the tank from the platform. The temperature connection shall be near the outlet pointing towards the platform. Now, next component is manhole. So, in manholes, this can be positioned on top, to side, or at one end of the vessels. Depending upon the vessel size, there can be two manholes. Here you can see the right hand side there is two manholes. Depending upon the vessel size, there can be two manholes, one located on top and other is located on the sail, accessible from the grate. Now next is vessel saddles. In vessel saddles, ideally saddles are located at 1/5 of the drum length from each tangent line. So each tangent line, so here you can see the tangent lines and the drum length from each tangent line. The verticals can be supported on the skirt, on half skirts, on legs, or on the lugs as case may be. The analysis of the support attached shall be done accordingly. Location of associated equipment around the vessel also influence the nozzle orientation. The liquid outlet should be located towards the nearby pump section. The elevation of the vessel should be such as to provide the required nominal pipe size height. In a reactor, the manhole should be oriented towards the axis to facilitate the manual feed if required. The utility manifold and the process inlet manifold should be placed at the operating level irrespective of the nozzle attached to the vessels. Piping should run overhead as short and as simple as possible. Pipe racks shall be arranged which will support electric and instrument trays along with pipelines. Piping should not transmit vibration and should be isolated from vibrating equipment with the help of expansion bellows or hose. Such equipments are centrifuge filters. Now let's see supports. Here support arrangements. Such equipments are centrifuge, filters, dryers. In all these cases, interaction with the manufacturers of the equipment will always yield positive results. While detailing the layout and piping, it should always be borne in mind that this should achieve the best performance as nice and detailed in the P and diagrams, that is a process and instrumentation diagrams. The structural arrangement for support also contributes a considerable part in the economic of installation. Certain economical arrangement of support is illustrated here, which are the that is a lug supported drums quite less economical designs, and if you change the lug supported drums, that is a more economical designs. So these sketches we can design the basic arrangements of the support arrangement in process industry as well as piping industry. So here we can see the more economical vertical drums and less economical drums. So the structural arrangement for support so contributes a considerable part in the economic of installation. Piping fitting components in the piping engineering industries, so as in process industries. So these are the for structural arrangement for support, and it contributes in the economy of installation different piping components. That are concerned the outdoor units when we install the reactors, that is a less economical and more economical. So based on that, we can define the structural arrangements more or less economic of installation in the process industry or petrochemical industries. Now next parameter is a distillation units. Let's see the basic about the distillation units. Let us analyze the equipment layout and piping design for distillation columns, which is more of an integrated unit than the individual equipment discussed earlier. Interaction between hydraulic requirement and piping configuration require close attention to many fluid and mechanical details in order to obtain the most efficient and economical distillation units. The PFD of a typical distillation column with bottom pump, thermosymphon reboilers, overhead condenser, reflex drums are shown in this sketch. During the normal operations, the pump transports the liquid in equilibriums. The arrangement should be such that the nominal pipe size requirements of the pumps are satisfied. The pump normally has a dual service. The pump head requirement should be selected to suit both services. The pump can also have simultaneous operation. All alternatives should be investigated while selecting the reflex pumps. Now, the reboiler circuit could be either pump or thermosymphons. The design of pump reboiler circuit is similar to that of a reflex pump systems. The bottom pump transport the liquid through a heat exchanger and return to distillation columns. The possible two-phase flow in the pipeline after heaters should be studied. The reboiler could be sail or tube type, vertical or horizontal to kettle type. In large diameter towers selected, U-type nozzles and inserted directly into liquid space. Two tower nozzles are also used. Helical coil inside tower are also can be used for small duties. So the distillation columns we can use kind of components reboilers and can also use helical coils inside the tower can be used for small duties. Now next is equipment layout. Here you will see the elevation and layout, that is a piping around the distillation columns. So this is the elevation, and now second is the plan. So based on that, we can define the equipment layouts. The equipment components are located adjacent to each other in a process plant. Now here you see the arrangement of principal element to integrate into the overall plant layout. So this is the overall plant layout. So you can see through the elevation and plan. So first sketch is elevation. So here to consider different lines with both ends higher than top line rack. Then lines with one end below and other end above pipe rack elevations, and lines with both ends lower than bottom pipe racks. And here, seeing the pipe rack arrangements, alternate locations, access to pumps, and here grade elevation is provided, that is 100 meters. And alternate section lines, pump suction, control valves. Here we can consider the reflex drums, condensers, manholes, okay, the road and reflex drums. This is the overall arrangement principal layout the plants. And through this elevation, we can visualize the view, plan, and elevation. The tower is located adjacent to the rack so that the lines can be dropped directly onto the rack and drums. Turn left or right. The plan view here, the plan view of this tower shows the segment of the tower along its circumference allotted to various utilities. Manhole faces, the access roads or access siles in case of indoor layouts. Platform is provided below each manhole at a distance of 750 to 1000 millimeters below the center line. This will facilitate maintenance as well as access to instrument and walls. From layout point of view, it is preferable to have equal platform spacing and orientation of bracket lineup along with the entire length of the tower. This will minimize the interface of the piping. And most reboilers are at grade next to tower with centerline elevation that is 1.5 meter to 2 meter above ground. This is to facilitate two bundle removals, maintenance access to wall and instruments. In this arrangement, static head is well determined between the exchanger center line and draw off and return nozzles on the top. Vertical reboilers are supported on the distillation column or adjacent to it at the same elevation. The details of support on the skirt or on adjacent structure are worked out considering the temperature of operations. Some reboilers have condensate or liquid holding pot located after the tube side outlet. Is shown in these elevations. When high capacity steam traps are provided, the top of the condenser pot should not be higher than the bottom of the exchanger side to avoid flooding on the tubes with condensate, adversely affecting the performance of the exchanger. Process condition determine the precise relation between the exchanger and the vertical condensate control plan shown in the this arrangement. So here we can see the bottom of reboiler should be elevated just above top of condensate pot. So through this sketch here, the P and D diagrams, that is a process and instrument diagram for a kettle type reboiler. This arrangement in the reboiler is elevated to meet the NPSH requirements of the centrifugal pumps. So here we'll see the different arrangements. So here condensate pot regulates the liquid level in exchanger tubes and physical relation between the liquid level in compound condensate pot and required liquid level in exchanger tube is important. And are the two arrangements can consider the elevation difference marked as H. This figure provided the static head for flow in reboiler circuits and overcome friction losses in the exchanger. Down corner and return lines, the pumps are located below the rack as per the details indicated in the section of pumps. So, with the help of arrangement, we can locate the equipments, this particular arrangements. Now, next parameter is piping layout. In piping layout, so in this segment, used to locate down corner from the column is as indicated in this sketch. The area segment of piping going to equipment at grades are available between ladder on both sides of manholes. For economic and easy support, piping should drop immediately upon leaving the tower nozzle and run parallel and as close to the tower as possible. The insulation thickness of tower and that of any possible flange on the tower as well as a line should be considered while deciding the distance. The vertical line can be suitable location for a straight run of an orifice. The horizontal elevation after the line leave the vertical run are governed by the elevation of the main pipe rack. The lines to run up further to the rack can approach the rack at higher elevation considering the size of other horizontal lines and be placed on the top tire. These can turn left or right depending upon the plant overall arrangement. Lines running directly to equipment at grade, more or less in the direction of pipe rack, often have the same elevation as the pipe bank. So, then lines from the tower nozzles below the pipe rack should approach the pipe bank below the rack elevation. The same elevation is used for lines that run for pumps located below rack. The pump section lines should be as short as possible and run without any loops or pockets. The steam lines to reboiler are trapped from the top of the main header to avoid excessive condensate drainage to process equipment. These lines can run at same elevation as those lines approaching the rack from the tower. On distillation column, the largest lines are overhead vapor lines and reboiler down corner and return. These lines should have simplest and most direct configuration to minimize pressure loss and cost. The prime consideration in all these cases is the performance to achieve the process requirement integrated with economics of the process plants or chemical plants. Okay, here our piping layout and equipment and piping layout. This is finished. Now in next lecture, we'll see the mechanical design fundamentals. Now, do you have any questions, any doubts, any confusion? So you can ask your doubts or confusion. Ah, yes. Sagar, Anjali, Vijay,
No, sir, no doubts.
okay,
No doubt.
Prajakta, okay, fine. Sakshi,
No doubt, sir.
okay, fine. Then I think we'll close this session here and we'll continue tomorrow with mechanical design and fundamentals of piping engineering layout. Is it okay to everyone? Yes.
Yes, sir.
So if you have completed, you can upload your assignments. I think will not restrict any dates. You can understand to finish the assignment as early as possible and upload your assignments in Google Classrooms. If you want deadlines, so I will write deadlines. Yes. Do you want deadlines? Yes, Sagar, Ayush, Harshal, Srikant, Prajakta. Yes. Yes, Pratik. Okay, fine. Okay, fine. You take your own time, you read all contents, whatever uploaded, and try to write the correct answers and submit your assignment. Okay.
Okay, sir.